What are the key challenges in implementing additive manufacturing technologies in this country? And how can we overcome these challenges?
But if you look at the technology, not much progress happened. Because whatever the technologies today we are talking, they're all developed more or less on the same period, first 10 years. Okay, it is all developed elsewhere, but yes, 10 years. But what has happened is people work further on the different aspect. I call it as aspects related to 4 P's. That is to product, then the process, people, and the production. The product means 3D printer. If you think that, okay, as a manufacturer, as an investor, even today, to it validates. If you think that any component I can make, I'm sorry, it is not possible. You need to design the component to manufacture by additive manufacturing. And unfortunately, design of additive manufacturing is still not kind of subject taught in the school, and also it's not, at least in the MSME, that level if you take, this is not their subject. Then you look at the process, process improvements, lot of process improvements happened, but new process development has not happened. But one area it is growing is hybridization of the process to meet the specific requirements. The people is still, it is limited to maybe autonomous institutes, NITs, IITs, where faculty teach as a course. But if you look at go at a university level, still this is a chapter. In even many universities, not a chapter also, because curriculum is not part of a curriculum. And then the production, if you look at, one is equipment. Equipments made elsewhere. It is affordability is an issue, and equipments or the process are specific to a specific application or the material. So naturally, interchangeability is the challenge. And the third one is even science is not understood to a large extent how the additive manufactured components are comparable to the rolled or cast or forged components. When I look at a replacement of these components by additive manufactured components, particularly in the metal, so it is really challenge. And then the supply chain. Supply chain is still we don't get a material, particular countries like us.
Adoption of technology is a challenge for industry. Now, when we are planning to adopt a technology to the industry, there are 3 M's: man, machine, materials. We agree? We all have seen. Now, man is the skilled manpower, your technocrats. Machine is of course your 3D printers, which you want to use as an alternate to the existing facilities available. And material is our raw material. Clear? Now, we are very specifically discussing here how academic institutions can bring up in generating the next generations of design engineers. If I analyze it very carefully, NIT Warangal was the first NIT, up to best of my knowledge, which started PG program in additive manufacturing. It was started in, I think, 2019-20 or 2020 from academic year. As sir told, that some of the institutions, especially technical institutions like NIT, IITs, they are having one subject, additive manufacturing. But when we are looking for generating the next generation of design engineers for additive manufacturing, do you really feel those efforts are sufficient? Of course not. So either the institutions are not having any laboratory for additive manufacturing, or they are having very limited exposure themselves. So first of all, the leading institutions like IITs, NITs, triple ITs, or central or government institutions should take a lead in this, and they should draft curriculums in very specific domain, because additive manufacturing is not simply for mechanical engineers. or manufacturing engineers, additive manufacturing is a common or multidisciplinary area.
And today every industry is looking at the speed, and be it by manufacturing, be it by automotive, I think the story isn't different. So from that viewpoint, so automotive industry where I represent from, so we are looking at rolling out vehicles within the next 2 years, every 2 years. Earlier it was 4 years, 4.5 years. Today, 2 years. So, but how do we do these things? It's not only, you know, working on various aspects from design to manufacturing to technology in automation, digitalization. One key thing is from the design concept itself, how much time we are taking to realize the actual customer requirement, and that is where this AM is so important for us. But when we really see that, how industry can leverage this, I think the big drawback or the challenge what sir was also talking in the initial part of our discussion and what now professor also told, I think still there's a very big gap of understanding what is really AM or 3D printing is about in many of the segments. Many of the R&D centers of many big organizations and small organizations still have a very limited knowledge about AM, the merits of AM, and very important as said that technocrats who can really understand and implement and execute activities related to AM. So from that viewpoint, it has to be an approach of wearing a L board again. Not just when we get our two-wheeler or a four-wheeler driving license, we wear a L board, and you know, with lot of josh we used to do when we were in the youngster days. But I think we have to keep wearing that L board. What's that L board? L is first listen. Listening to the requirements of the customers, listening to the requirements of the industry, and at the same time listening to the technology in opportunities where we get like this. One is that L. Then once you learn, once you listen, then now learn. We have seen that today morning he was talking about the programs, certificate programs. I was discussing with Arish, Professor Arish, about the programs they do. Honestly, before coming here, I never knew there were such programs. So we have to learn. Then once you have learned, what is the use if you don't leverage the technology, leverage the process? So it's all about being L, be a permanent L board. If we are having that L board in our thought process, then I think every industry can definitely make a big step towards leveraging this AM and contributing to the development of any product or any technology driven process within their organization. And we as industry people also need to work closely with academy, as he was talking, and bodies like CMTI and NIFT, NIST, so many such things which we normally do not get connected. So I think those are the ways in which we have to look forward to from the industry point of view.
Thank you so much. I think you should patent this, this L board thing that you said. Listen, learn, and leverage. You can actually write a book on that, and I can help you on that. Okay, Sarvanan, I'll come to you. You know, when I was looking at Anuj's presentation, there was this young engineer from Vestas. He made a very interesting statement which caught my eye. He said that this is about a rapid response to a fast-changing product, which is really, relevant in today's point of time, because Tej-san also mentioned about speed. So speed is, of course, one of the key drivers for adoption of additive manufacturing. What do you think would be the other key drivers? Why should the industry adopt key additive manufacturing?
Thank you. First of all, thanks for inviting and organizing this summit, where we have all the already people talked about the learnings. So even last few minutes when I came here, I started learning a lot about the course, what NIT is planning, or various the NIFT solution what he showed. So a lot of learnings in the industry. So the speed, for example, if I have to show a model to my senior management, if the product designer wants to show, it is easy to draw and show the thing. But how it looks like as a picture and how it looks like as a model, real model, varies. So if I have a 3D printer at my company, I can print it and show in the same size, in a much cheaper cost. If it was in the traditional way or the conventional way, it takes several weeks for me to show the design what I want to show, or anyone wants to. So it really leverages in terms of speed and the creativity what we want to have immediately to display it and give a feel. This is what we want to manufacture. And when we see that, we can modify it. Okay. And when it comes to the other way, it takes a lot of time to modify the changes. We might not like a portion, but it is too late to modify it. When we have a 3D print in our hand, we can do all the changes. If we want to add strength in an area, we can add. If we want to do a stylish finish, we can add. And it also have a lot of flexibility in styling. Okay. If a particular area, I can't do it in a conventional manufacturing, I can just 3D print and remove the strength portion and do a styling only and do a surface and give it to that. And the reinforcement can be done in the conventional, where hybrid things are very important. I'm not sure I'm answering your question, but
Yes, of course you are. Yeah.
okay. So that way it's really mesmerizing, but lot of gaps. As we already talked about challenges, I don't want to repeat. I just want to reinforce one more thing is on the understanding what already Tej sir explained. Even in my organization or with my colleagues, it's very hard to really convince people why additive manufacturing is required. So this summit is one of the what do you call platform where we come to know, but we need to spread more on the benefits. And it is not just a tick the box. Everybody is adopting additive manufacturing, let us do also. It is not that way. There is a solution it is going to provide on specific pain points. And when we really use that, people will come to know and start enjoying the benefits. And the overall globe, the revenue of this business is close to 25 billion, sir. It's expected. And India is in decimals. And even our ministry has a vision to make it into 1 or 2 billion in next few years. Even if we achieve that, that is great for India actually. Thank you.
Wonderful, wonderful. So let's give a big round of applause to the organizers for spreading awareness about this technology. And as you said, it is very important to take the message to the industry, and this is what this platform is doing. Prashant, I saw that you were smiling when Sarvanan was answering, and a lot of things resonated with you. So I have an additional question to that, in the sense that how can additive manufacturing, and this will benefit all our audience also, benefit two key issues that this industry wants to address. One is manufacturing of complex parts, and number two, while you are doing that, also bring the cost down.
So first of all, many thanks to all the respected participants as well as the panelists. So first I would like to put a key stress on, we all need to accept change in our mindset. Now the journey is not difficult at all to inherit this technology. It's not all about Markforged, any 3D printing company. So any technology, additive manufacturing, is easy to adopt. As sir said, from CMTI. So definitely you cannot replace 100% everything, because there are limitations to some material properties, as well as we are all bind towards what we have been doing for design for manufacturing for so many years. And we'll keep on doing that. Now this technology is going to act as a catalyst, is going to complement your traditional manufacturing. It's not going to replace at all in future also. So there is always a fear when I go to industry. So most of the people think, is it going to take away our job, or is it going to replace the entire manufacturing scenario what we have today is going to replace that? No. So what we need is first is change in mindset, because we constrain ourselves with the boundary conditions with our daily routine of work. So my job is to create awareness in India. I do a lot of walk the lines, apart from business operations. That's because that's in my DNA, product design and manufacturing. So I do the walk the line and go and see the customer pain areas. So additive manufacturing, you can definitely solve, I would say, close to 80 to 85% of the problems you can definitely tackle with direct. And there is always a solution as a hybrid. So don't take it as that I have to completely replace it. Some of these solutions we are not able to do directly. So there is a way you can design it as a hybrid solution. So Markforged is a solution which will strengthen manufacturing resilience by bringing this industrial production at the point of need. There's a unique industry platform, what we call as a digital force, is nothing but is a connected ecosystem of printer, which is a hardware, material, and a software. And the software is a ISO 27001 certified, which is a security enabled. It means it's a cloud-based software, but your data is not shared on the cloud. It's safe to use. Now you can scale up your entire, design process or the manufacturing, bringing down the, improving on manufacturing efficiencies by support of the Markforged different altogether with composites and metal, or maybe the combination of both as a hybrid. You can work and take this through a long journey. So that's our complete product portfolio. To start with desktop printer Mark II, and then we have X7. It starts with the industrial printer. X7 is very special to us. It's also equipped with a laser micrometer, which scans your bed. Maybe you must have seen a normal engineer working on a CNC milling with a dialing the bed or a work. Whereas here it's totally automated. A laser micrometer dials the bed automatically within 2 microns to 10 microns. And the other benefit of this laser micrometer is you can scan each and every layer while printing your part, which means post-printing, you can quickly have your dimensional report. You can customize that report as per your requirement versus the printed part versus the CAD file. So that is very unique that Markforged has brought in this. And then already FX20 you have seen. Metal X is a technology based on a wire-based metal filaments, similar to what you see at FFF or FDM technology. And then what you see as a FX10, which is slated to launch this year again, is a new printer. We are coming with a smaller size with 375 to 300 by 300 millimeters. And then what you see is PX100. I'll talk about this in my next slide. It's a technology for mass production. Okay, so that's for metal, where the material is in the form of powder. So let's look into the composites overview. So to start with, basic polymer, what we call it as plastic, is Onyx, which is a combination of nylon stick with chopped carbon fiber. And then we have Onyx flame retardant material. We have Onyx ESD, electrostatic dissipative material for the electronics assemblies. You want to print any enclosures for your PCBs or electronic enclosures. You want to keep it safe away from outside surges. So we have ESD material as well. And then we have a basic polymer PLA, the cheapest material available on earth for additive manufacturing, to do all the visualizations models. And then we recently also launched TPU material with 95 Shore hardness. And then coming back to high temperature material, we have Ultem 9085, which can also be reinforced with carbon fiber. And then we are launching the material called PEC. So it's, you must have been using PEEK from your injection molding. We have slightly altered this to PEC. So PEEK is polyether ether ketone, where PEC is polyether ketone ketone. So we are coming with PEC. So just to avoid those warpages issues while printing, we have slightly altered so that we meet that industry requirements. A small video about our FR and aerospace grade materials. We have ESD material, as I said, so which is capable of high fire resistance. We have a complete spec sheet. We can share it with you. Now here comes our patented continuous fiber reinforcement technology, which enables our customers to move from design to manufacturing floor, where you can do a lot of jigs and fixture applications, manufacturing aids, toolings. If you look into the top side, left side of the image, the parts which is printed like we are printing right now with Onyx, that's the plain polymer that we are printing. And if you want to route it through a fiber, one at a time. It can be a glass fiber, Kevlar, or carbon fiber. So what you see the image at the bottom is. So when we print with onyx and if you reinforce with carbon fiber, so we are almost 25 times stronger than the normal plastic like ABS or ASA or the PC material what you see in the market. So ideally, if you see our onyx alone is replacing your 5 different plastics to start with. ABS, ASA, PC, or maybe nylon filled materials. Metalex, so we have 2 different technologies. One is based on a triple F, fused filament fabrication, where the material is in the form of wire. And the new technology that we launched this year in January is binder jetting. So I'll talk about this. So Metalex comes with a comprehensive solution, the printer, wash system, and a sinter furnace. Okay. So the maximum size of the part that we can do is 235 by 120 by 130. And it's a greener technology. So when you have this printer in-house, so you don't need wire EDMs or any others machining to remove the support materials. So when it prints with a ceramic release. So wherever the geometry is printing and wherever you have the support material, so in between this support geometry and the part geometry, system automatically releases a ceramic release. So you can easily remove through your pliers and that and start using it. So the present metals what you see today is you get 17.4 pH stainless steel, then you have S13 tool steel, you have A2, D2, you have Inconel 625, and then you have copper. That's a very interesting technology that we have brought to the market, and it's a binder jetting where the material is in the form of powder. We can go to a printing speed of 1000 centimeter cube per hour. Now the bed size is 250 by 217 by 186. So you can print small parts all together, maybe 1000 or 2000 numbers, maybe nuts and bolts, or maybe any critical parts in terms of this technology has no limitation in terms of complexities. So this machine is capable of printing an RS 6 micron finish within 50 microns accuracy. So the part, maximum size of the part, what you can print in 50 microns is 100 millimeters. Okay. And we have 10 different materials qualified. We recently qualified gold also for one of our customers. Due to NDA, we don't take the name. We don't provide gold because they have a lot of stock of gold in US. So they do a lot of jewelries, the watches and all that. So it's a very renowned company. So any material which can be sintered, we can do this. Say for example, any medical industry comes back to us, say we need cobalt chromium. So we can work with them. Our scientists can develop that material and make it through. So any material, it can be done, which can be sintered. Yeah. So that's the total library. So we have 316L, we have Inconel 625, Titanium 64, S13, Inconel 718, 17.4 PS stainless steel, Maraging steel, copper, D2 steel, and 414. So if you look into the geometries, you can see how critical and complex geometries we can do. The machine is on a monoblock granite block structure of 160 millimeter height solid block with the air bearings. Absolutely no powder dispersion outside. So very no health hazards. Then coming back to our software, so our Eiger software runs on a Chrome browser. It's a very small program which is a cloud-based. That's the security certification that we have, ISO 27001 around the Eiger. Then we have a simulation software that we launched last year. Now idea is to bring that any new user, if he wants to do any design from manufacturing to design for additive manufacturing, and if that part is subjected to any load, maybe to a certain direction is maybe 200 megapascal or 100 newtons, whatever it is. With a factor of safety, you can apply and do the changes and routing of fibers, and you can see the results. If in case you are not able to do the manual, calculation, you're failing, your parts are failing, you can ask the software to do it for you. It will do automatic optimization and give you different permutation and combination with all the economics of print time and the cost. So why we bought this software? Because that was the need of an hour, because most of the companies, if you see 3D printing, they don't have this software. So idea is when you print this first part, you print correct, and you are not doing a lot of tinkerings. You're not wasting the material, not wasting the time. So you visualize the design intent, the application intent, what you have, and you have a success when you print the first part itself. So we started with last year with Onyx with carbon fiber. Now we can do also simulate glass fiber, and we have recently qualified stainless steel also in this. As I talk about that, one of our machine has laser micrometer. We do also have plan to bring laser micrometer somewhere near in future on this machine also. So you can scan the parts while printing each and a layer. You have to just click a button on the software if you want to scan it. If you don't want to scan it, is okay. So it scans each and every layer. So laser micrometer has a beam of in X and Y it does in 50 microns, and in Z axis it does in 1 micron. So rather than depending on your CMM labs or within your QC labs within your department, you can directly have, once your part is finished, you can have a comparison report versus the printed part versus the CAD file. So this is how the scanner does. If you see the red spot, this is how it's scanning. Just to give you a visual representation, this is how it scans the parts while printing. Just to give you a graphic resolution, this is how it collects the data, point cloud data. The red spots you will see, it will show you different tolerances. Is out of whatever the tolerance band you can manually adjust. I want to, have a complete report within 50 microns of cloud, or maybe I want to check this part in within 100 microns. So it will give you that. If you want to check this distance between the two center holes or any features, you can do that. So it can be customized. Markforged University. So I think we are the first company, I would say, in the world where we have beautifully crafted this program. There are almost around 40 different courses around how to use our technology, and also on design for additive manufacturing. Till last year, we used to charge around $2,000 per student, or maybe per individual. Now we have made it free. Whosoever a customer is, even if you have 10 people or 10,000 people, doesn't matter. So you can have an organization-wide access to this course. Now, going to Markforged value proposition, how you can have on-demand manufacturing, breaking with your traditional manufacturing methodology.
Running your manufacturing
Okay, so
operation
talk about the digital
has
force, a
never
small
been
video.
more challenging. Frustrated customers waiting for parts, increasing workforce and supply chain challenges, expensive inventory cost. It's time to digitize your supply chain. Introducing Digital Source, a platform for 3D printing OEM certified parts when and where they're needed, without the cost or hassle of physical inventory. Customers can securely license parts from your digital catalog of certified OEM designs and 3D print parts themselves on location, instantly, or through a growing distributed network of trusted print providers. OEM certified parts when and where you need them. Once in Digital Source, always in stock. Digitize your inventory today with Digital Source from Markforged.
So this platform is going to help you create your own IPs. You can put it on our platform. Say, example, you have multiple branches. You have your company branch here and that, and you have a printer over there. Even if you don't have a printer, you can look into our services where our printers are activated, and you can get it printed there. So value proposition. So Markforged has made this industrial 3D printing very easy to use. Now, what is the offer here? As if you look into the traditional manufacturing, I think my colleague already covered. I'll just put it a little more detail. So when you do traditional manufacturing, there are multiple stakeholders. There are programmers, there are operators, tool designers, and then you have different processes. You are dependent on that. So at the time when you get your part in hand, you see that it still has to go from T1 to T2 or T3 different trials, and the journey is long. It takes a month's time to realize the final part in your hand. Now, if you look with additive with other 3D printing players, so the process is same. You slice the part, you print, but in between, the process of with their software is very tedious. Expertise required is very high. Compared to our software, it will just take half an hour to learn our software. And then you will have to also invest into post-processing equipments, auxiliary equipments to post-process. Whereas our post-processing is very easy. It's just a peel away separate. You don't need any chemical bath. And in India, there is no STP, regulations. You throw that chemical outside in the field, and then we drink that water from the same field. So this is where the Markforged is totally, whatever the technology we are coming out is more of a greener technology. And what you can do with additive with Markforged is just one stakeholder. You don't need any very high skill labor to operate this machine. It can be a designer, operator can be used. And then you can release a lot of capacity of your existing workloads on the machine, improving productivity with our Eiger simulation software that we launch, and then automated part inspection in place, as well as the Markforged University program that you can keep on regular churning, even if the person leaves that department and goes to other. So you are always in a safe hand, you understand who's going to use this machine. And we are always there for you to, keep on churning that program. So let's look into this part. What I'm trying to show here on the picture is a part printed with our technology and an aluminum machine from a CNC milling in 3 different setups. So if you see a part printed within 10 hours versus machine in 2 weeks, you have gone outside for a vendor. There are direct costs and indirect costs also associated. You do purchase orders and all that. You waste a lot of time. And even if you machine it in-house, you have multiple setups to do. And if you want to go for a 5-axis milling, again, the machine is very high cost. So if you have a small printer or maybe medium-sized printer between your manufacturing setup between 2 CNC machines, so I'm sure it will take away the load of your existing CNC machine by 50%. So if you look into the process, so the tribunal cost was just 1178 rupees versus the 5276 done in multiple settings. It has gone through. If you see the process, you have just imported the part from any CAD software in a steel format, chosen the orientation. If fiber is required to add, you add it and just print it. Just press print. Whereas if you see the below process conventional, you are going to import the part, you have to program the part, you need the toolings, you need the skill programmer to do that expertise. Tooling cost is associated, which is heavy. Then design fixtures. Okay, if it is only the product machining or design fixtures, you have to accommodate with both the things. And the overall time, what you see is 2 weeks. This is how you are able to, reduce time. Now, if you look into the value proposition, the graph, what I'm trying to show is value generation is relative. I'm not talking about any hobby printer, what you do with a PLA or you want to print a toy. This is not where Markforged is. So if you look into the yellow spots, where we are able to do functional testing, validation, work holding and alignment tools, service and maintenance tools, MRO applications you can do. You can do bending and forming. So we have also done a lot of toolings with our composers with continuous fiber V-bending tools up to 1.5 millimeter of sheets we have bended across. We have done forming of the sheets with our composite tooling. Our existing customers are doing in India. We have done pipe bending tools. We have bended pipes with our composite material. So this is where, Markforged is heading to. You look into the vision of the company with the digital source platform which has been launched, then the Markforged University platform, then Eiger simulations. So you can see the what our management, the kind of portfolio they are putting it so that our customers can use this technology to maximum. Yeah. So just to keep it very short, so time and cost, you can definitely reduce manufacturer's time. And the biggest benefit is you can start functional validation earlier without tooling investment. So you are not going to invest into your capital tooling cost or soft tooling cost. I'm not able to share you today. I have done an injection molding. We have printed a core and cavity out of our Onyx with HSST glass fiber. We did almost 70 to 80 shots in polypropylene, then ABS, and then nylon with 15% glass fill. Due to NDA, I'm not able to show you the videos and all that. What I'm trying to do is we have tried to flex our muscles to the extreme. So not only beyond prototyping, we have moved from beyond prototyping to manufacturing. And then time to print and the faster time to market. So if you look into the what FX20 gives in opportunities today is really for the production support. You can do assembly tools, you can do jigs and fixtures, part validations to start with, aftermarket spares and parts, production parts for low volume and customization. And you see the key drivers, what is cost and time savings, which is going to impact compared to machine tools. You can also support your vertical integration within your interdisciplinary departments within your organizations. Easier implementation of ergonomic and safety fixtures you can do. Very small example I would like to run here is, now if you see, I want to bend a 1 by 8 inches of a tube, close to 3 millimeters hollow tube, steel tube. So the process will be what? The process, either you will go for maybe a pulley, you will do a machine on a lathe or maybe milling. There are undercuts to do the grooves. And I'm sure it will take at least minimum 4 days time to do this bending of this 1 by 8 inches tube. So I'll just run a small video. It's a very small part, but gives a very large impact in terms of how this technology can be implemented. Now this 4 days work just done in 4.5 hours time. It's a small tool. All the assemblies put in together on the machine, printed, finished. So this is what I would call it as a Kaizen. What improvement you are doing in your manufacturing floor. So it's a small example, but when the company realized this first part, they bended it accurately, what bending radius they want. They went for automating all their hand tools, small tools, all whatever they were doing for machining. So you see the impact. You see a small part. This is what I call it as peel away support. So very easy to remove. Now think of part if you want to dip inside a chemical bath for many hours, where it is totally going to depend on your skill of person. If he forgets that part inside a bath tank over the night, and your plastic will absorb a lot of water and moisture. And then difficult to manage those harsh environments of those chemical baths, keeping that, maintaining that. So easy. You see, this part was earlier through a gravity die casted aluminum, which has been printed with our onyx with carbon fiber. Lot of examples you see, small fixtures on the left side, a big drum, manifold, lot of parts with vacuum and pneumatic, fixtures. Some of the fixtures what you see is steel. The blue and yellow, the idlers, you can say rotating, that's the PLA material. Even if you see our PLA, we call it as a precise PLA material, which is better than what the other company offers in market. You see the bracket here side at the extreme left bottom, which was earlier in steel, we have replaced to carbon fiber. You see a lot of the tools and fixtures. So rather than going for a subtracting method, taking steel different blocks, machining it, grinding it, making it right angle, and then coming out. So maybe the bottom plate can be aluminum on that. I'm not going to print a plate. It's not complex in nature, will not be a cost effective. You can do that. You see a fixtures over there, headlight fixtures. The clamps are water parts, but you see how quick you can do. And any center holes which require precise, you can ream that within that accuracy. So that will also not take much time, hardly in half an hour or 1 hour to time to do that. So this is where I was talking about the hybrid solutions. That's, if you see that product assembly with all validation done for, how gears will perform, what will be the interference before launching that product, before investing into capital tooling costs for the large, for multiple lakhs of rupees, and just done in 5 to 6 days time. And if you see a pipe profile gauge tool, now a lot of people in automotive, they use Ciba wood to machine this, and that's very expensive. And then all this picture what you see is hollow from inside. And I go to people, they say, can you do it in 20 microns? I said, no, I can't do it in 20 microns. But why not? Where the pipe is sitting, you just keep a 0.1 or 0.2 minimum material and just take a skim cut on that. Just 1 hour of machining time. Even it is saving huge lot of money and time for you. And then it's lightweight, ergonomic. Worker fatigue is reduced. Lot of machining holding fixtures. If your components has been done short blasted or sand blasted, now you want to hold it to prevent it from, you want a non-marring surface to prevent it from scratches. All those fixtures you can hold it on machining and you can do it. It's all possible. That's a live example we did for, you must have seen a Jimny car from Maruti. So the extreme bottom image is a Google image, since they did not allow to share the image. So they were looking for a part, polypropylene with 20% glass fill. I said, we don't have that polypropylene with 20% glass fill. So what is your end criteria to, make this part successful? What is the tensile load? What is the crimping force? What do you have? We'll meet that. and also keep the 20% further factor of safety on that. So if you see that part is prone to very high crimping force for the radiator, and the first part, they literally had thrown on the floor. I said, you throw it, break it, whatever you want. It did not chip off also. And the part validation was there, functional testing was there. They have saved huge money. We printed the radiator also for that car. That went to the calorimeter for the 100-degree test, 150-degree test. Did all the air suctions, went on the vehicle, did all the field trials. So this is where our technology is able to help you with it. You must have seen many companies doing a lot of machining fixtures around cooling jigs, because some of the materials like polypropylene or nylon, they are always subjected to stresses post injection molding. Now once the part is injected from the injection molding, you want to keep it on a jig. You need a jig. So you see the parts, rather than having a machined components, all the components except the bottom plate has been 3D printed. That's the fixture which is rotating at a very high RPM, some laser welding fixtures. That's our customer primed all, globally done. So clamps are bought out. So you see we have replaced the metal. We are gripping that part, steel part, and the stiffness of the material is strong enough to take that bearing cutting loads and that. See to this picture, the person holding that fixture for a hoses assembly. This was earlier machined out of aluminum weighing around close to 27 kgs. We just printed it somewhere close to 5 to 6 kgs just holding in hand. All box printed, assembled together, printed on an X7 printer. That time we did not have this large printer. Had we had this large printer, we could have done it maybe 3 or 4 segments together. Some of the customer case studies. So I'll just play a last video, Cedar Space. So they recently launched a satellite. They are using a machine in US. I'll just
standing by for launch command. A lot of the ideas that we're working on have never been even thought of yet. We came up with an idea of a 3D printed satellite, and I'm constantly thinking about how to make this lighter and stronger at the same time. The entire satellite cannot weigh anything more than 100 kilograms. Eating up the biggest portion is large batteries, computers, all the parts that go in it just to make it a satellite that can function in space takes up a lot of the weight.
The whole concept is that you should be able to build a platform that services multiple industries, multiple customers, multiple countries, multiple companies, as opposed to just being focused on one particular industry with one particular sensor. So you're not sending up, hundreds of satellites focused on different things. Instead, it's one satellite that can service many.
Every ounce matters, and it's not only just making things to hold the payloads, it's changing the structure itself. The more weight I bring out, the more payloads we can put in, which gives us the advantage by 3D printing everything. I can make changes on the fly, and it goes into the next structure.
We're designing LizzieSat for a 5-year life, and so we want to make sure that our material is going to last that long, so we continue to support our customers that entire time.
A satellite has to be really strong. It's got to take 5G load and launch. 5Gs it's basically 5 times the weight of gravity. If something weighs 5 pounds on the inside, it's going to weigh 25 pounds at launch. If it weighs 100 pounds, it's going to weigh 500 pounds at launch. When it gets into space, it has to take a lot of solar radiation. And then there's the temperature swings. On one side of the Earth, we have the sun. The other side, we have the shade. So the temperature swings are anywhere between 300 degrees Fahrenheit, 200 Celsius. There are numerous specifications to make sure that what we're putting on the rocket is actually going to be able to go through the launch, be deployed into space, and perform as it's expected.
How does Markforged adapted that?
We actually received a grant to build a flight test platform. It's the beginning stages of a satellite, so you were able to send that up to the International Space Station for a while and then bring it back down and test those materials.
So we rapid prototyped the sample holders out of onyx, and we put them in this experiment and went up into space. This went up, and as you can notice the degradation, because it was white, but the sun degraded it so much being out in a space environment, and all of the onyx parts, no degradation whatsoever. There's no difference between a part that's just come off the machine and what's been out in space for a year. I think everyone was surprised by it. I believe that everybody thought that when the parts came back, there was going to be total degrade of the material. I believe some people thought that it wouldn't even have lasted through the entire experimental process. The Markforged material took all the punishment and came back looking just like the day we printed it. It was perfect.
It was on the outside of the ISS for a year. That wasn't the original intent. It was supposed to be like 15 weeks. It was outside for a year, came back down, and that material's great and it's intact. And so we know that it can survive. And that's why we're excited about having Markforged as the base for LizzieSat.
We're using continuous carbon fiber throughout the entire structure. It gives it strength similar to aluminum. If we were to use aluminum and we had to make a change that would take a considerable amount of time just to get the design change made and then manufactured and put together, you couldn't produce something as fast as when you're 3D printing. With what we're doing right now, if something changes, I can reprint it, and in a day I can have brand new parts.
Markforged is just, it's so economical, you know, and the speed at which we can manufacture a satellite bus is unbelievable as well.
See you later. It's not only making the parts so they're able to print, it's also making the parts so I'm using the least amount of material so they still pass analyticals. Not a lot of people think about how much a screw weighs, and if I could remove those screws from the assembly and somehow rapid prototype a fastening feature, I'd take that weight out of it. This part right here, it falls into the slot and then locks into place. And when it's bolted in place, now it's not going anywhere, no matter what you try. And this keeps our entire satellite structure together. You can't pull it apart because the design on the inside is so precise. If it was off by a few thousandths of an inch, it would easily come apart. 10,000ths of an inch off. It's less than paper thin. Yeah. It's like, yeah, cut it down. Yeah, exactly. And there's no way that you could possibly machine this feature. You could machine this end, but this end here, you could never machine. But it works flawlessly every time, and it's because of the tolerances are just perfect. We're starting to print everything with Onyx FR, fire retardant material, and we're also using Onyx FRA. The A designation gives us the traceability of the material, which is required by numerous companies. Traceability tells exactly where the material was made, so they can follow it all the way back. You get a crack, you get a shear, something happens that the analysis says it wouldn't, they could find out how the material was made and find out where the error was, correct the error, so the next time we get the material, it'll work. I've been 3D printing for at least 25 years now. So many 3D printers, you buy materials, one day it's like this, the next day it's like this, and you're trying to figure out, what am I doing wrong with your parts? Whenever I'm printing with Onyx, every single part comes out exactly as it's supposed to. There's no unknowns. I know exactly what I'm going to get, and it's working. It's working very well.
I don't think we would be doing this if it wasn't for Markforged, honestly. The idea of LizzieSat came out of that flight test platform, and it came out of using those materials. We've created this flexible model that we can put any technology we want in there and service, you know, customers, whatever their needs might be.
7, 6, 4, 3, 2. Launch day will be a really big day for not only me, but for everyone. Each project is different, and each one of these is an adventure because it's building something that's never been done yet. Once this one launches, I'll be looking forward to the next adventure.
So that was a successful launch from them and a very happy customer. I'm thankful to today we have people from Dhruva Space. I'm sure we are going to collaborate with them in India, and we'll similarly create that success story as well with them. So we have U.S. Military also using technology with both metal and composites for all their maintenance, repair, overall applications. Siemens, they have around 20 to 22 printers from us. So earlier they used to bring back their turbine to the warehouse and spend millions of dollars doing maintenance and repair overall back to the warehouse. Their engineers designed this cutback tool for the field engineers. Now they go and do the repair on site. So that's a huge, close to 1 meter long, printed in multiple segments. The white tube is a bottom part. The rest of the parts is a combination of onyx, carbon fiber, based on the application requirements they designed and fitted together.